Okay.
Oh,
I'm waiting on a reply. I sent him all the stuff. I'm waiting on a reply. I contact him. We still got if it's through next week. So, dry bulb temperature. Put a wet wick on it, like a shoestring works great because it doesn't fly off so easy. Shoestring on it works well. But before we had these digital jobs coming out, we had the sling psychrometer. So this is a digital psychrometer. This is a sling psychrometer. And this was what all the top techs had, was the sling psychrometer. And you knew the guy really knew what he was talking about because he actually had the sling psychrometer. I remember saving up to get my first one. All right, and then so now I'm like, I can't believe I used this. Why didn't we have digital back then? But on this we have two bulbs, two actual mercury bulbs. One of these has a wet wick that fits on it, and it's slipped off. But in this little tray, the rest of the wick fits up inside of here. And so what we'd do is we'd put distilled water here, and it would soak up to the wick, and we'd stick this on the end of the bulb of the mercury bulb, and we would sling it around in the air. Sling psychrometer.
That thing's it's an HVAC nut.
Have you ever hit yourself in the head with it?
No.
So you weren't trying to read it while you're doing it?
So I usually never checked wet bulb and dry bulb while I was at the bar, so I didn't ever do that. That might be different if not.
Yeah.
But you were sling around. Now, is the dry bulb temperature going to change with air movement?
Yes.
The dry bulb temperature?
Oh, no.
No, it's not. Will the wet bulb temperature change? Yes, evaporation. So you'd sling it around. Now, if I wanted to check return air wet bulb, I didn't have to sling it. I saw a guy, he was like slinging it in front of the return air while the unit's on. You don't have to because the unit's pulling air across it, and that ideally, if it's enough airflow, then it will cause evaporation. You can get your wet bulb temperature that way. But if I know the wet bulb temperature and I know the dry bulb temperature, we used to be able to put this back in, and we'd put the two numbers together here, the wet bulb and the dry bulb, and it would tell us what the humidity was. And this is how we found relative humidity before we had the digital jobs come out. So this is we'd get wet bulb and dry bulb and find the relative humidity. Well, nowadays they have the digital ones. It tells me humidity, dew point, everything. What's cool is on your app that you have, there's a lot of other things that it does. And there's a chart on there. If you open it up, the one we just used, there's a chart on there. Yep, under charts, let me see what you got on yours. Let's see. Go to wet bulb. Oh, that's not the one I'm looking for. Actually, stay on wet bulb. On wet bulb, this little calculator, you can enter in, if you know your wet bulb temperature and your dry bulb temperature, it'll tell you the humidity. So you don't even need, really you don't have to have those fancy tools. Just get a thermometer, get your dry bulb temperature first, then put a wet wick on it and let evaporation happen, and get your wet bulb temperature, and you can find the humidity in the house. How cool is that? So let's go to another one. Let's go back to our home page, or go back to chart. So there's a I'm sorry. Go back to the one that says wet bulb again, where we were. I apologize. And on the top right-hand corner, it says chart. So press the button that says chart. Oh, look at there. It has a wet bulb chart. And in my day, we used to use the wet bulb chart. If we had the dry bulb and the wet bulb temperature, it would tell us the humidity. So that's what this chart is. The calculator is just using this chart. Pretty neat, huh? All right, so let's go back. You guys can play with this at any time you want. Yours. Let's click on temperature. Go back to conversions and charts, and then temperature. So what does that pull up?
Input known, Celsius and Fahrenheit.
Look, Celsius and Fahrenheit. Remember when you guys did your conversions? There's Celsius and Fahrenheit right there. Right there in your app. So some of the equipment that we work with, some of the stuff's being made in other countries, and sometimes things will be in Celsius, and you'll have to, or set points, and you'll have to convert it to Fahrenheit to know what you're working with.
Do they have it for the Kelvin and the Rankine?
Not on this one, but if I want to convert Fahrenheit to Rankine, I just add 460. If I want to convert Celsius to Kelvin, I just add 273. Right, so let's go back to our the other screen. Oh, so conversions and charts. We also have a PT chart. Right, so you can pick what refrigerant. Yep, and you can, if you know the temperature, you know the pressure, or if you know the pressure, you also know the temperature. Pretty neat, huh? And there's a whole lot of other stuff that these will do. There's some diagnostics tips on there. There's airflow. There's stuff about when we get to electrical that's going to help us out. There's a lot of stuff on here that's going to be.
I found that one in the lab.
That's the one I don't like the most. It's lacking a lot. So
Too generic or too.
it's very generic, and
Doesn't give you all the.
I disagree with some of the.
So I'll just
things
figure I ever saw it.
It does say that it's going.
Like you picked the one on there I didn't like. Like I have all of them on there.
Yeah, verify all results.
Like
of
which
other
one would
sources.
irritate? That one. That's. I was just going to skip over it, but now you brought it up to me. Now.
That's my job.
All right. So any questions about what we've done so far? No. We good? All right. So let's talk a little bit more. Return air. Now, for target superheat, we get the return air wet bulb. But I can get wet bulb temperature of anything. I can get wet bulb temperature outside. I can get wet bulb temperature this room. If I have wet bulb temperature outside and dry bulb temperature outside, what can I find?
Humidity.
Humidity. If I get wet bulb temperature inside and temperature inside, what can I find? Humidity. I specifically need return air wet bulb so I know it's reacting against this evaporator coil. I can also, though, get return air wet bulb, supply air wet bulb, and the difference in that, I forgot what it's called, there's a name for it, wet bulb depression, I think is what it's called. And if you have the airflow coming through, you can actually calculate how many BTUs of heat you're moving out of the air, sensible and latent. I mean, there's a lot of stuff you can do with it. So I just don't want you guys, the moral of the story is, don't think you can only get your return air wet bulb in that one spot. Wet bulb I can get anywhere. I need it at the return air along with the outdoor temperature for target superheat with a fixed orifice meter device. So far, so good? Now, return air means the air returning to the unit. This is one thing I see that new students have a big problem with. For some reason, it confuses people. And everybody says, well, what if we changed it to this? It'd make more sense. And no, because then everybody that already learned it has to relearn it another way. So it's return air, the air returning to the unit. The unit sucks return air in. It's going to be air pulling into the indoor unit. In this room, can anybody identify where the return air is? That square one, that one square one over there by the opening, that's a return air. The unit is pulling air from their room, and it's returning that air to the unit so it can take the heat out. Now, after the unit takes the heat out, pulls some latent heat out, cools the air, we're going to put that air back into the room. But now we have another name. Now that the air is coming in, we call that SA, supply air. Supply air. That's the air coming back to the room. Can you see which vents are supply air?
Yeah.
Yes. For some reason, right now it may make sense to you, but tomorrow or the next day it may not. So please make sure that you study on that one, because I do not want you to go out to a job at an employer and be like, yeah, I don't remember which one's return air and supply air. I get those mixed up. Ooh. No, you can't get that mixed up. I mean, it's a big deal.
Is there a reason why the returner is always grid?
Yes. And one of the reasons is this supplier here, see how they have the different layers? If it's done well, we want to take the air and blow it out across the ceiling, and that air is cooler, so it's less dense, and that air goes out equally across, and then as it comes down through the warmer air, it equalizes through, and you never know the air is on or off. As the air mixes, it keeps the air comfortable as that air comes down, and you never know it's on or off. The return air is just pulling the air back through it. It doesn't need to be pulling from different directions. It's pulling the air back to it, so it doesn't need to be angled or gridded out.
So if one section,
say something he's going to add. I thought.
No.
Okay.
so if one section of the room is colder than the other, that means that's not work functional right. Then it's all right.
Well, ideally, you wouldn't want just one there. Ideally, we'd want to have, if we're going to have just one in the middle, would be better. So it's pulling from the central of the room. Or ideally, I would want to have my return grills above my windows. So I'm pulling my heat. As the heat comes in, I'm pulling that location in. In a house, you always want, or even in commercial buildings when possible, you always want your returns on the opposite of your supply. So if I'm blowing air this way from my supply, I want my returns over here. So I'm blowing the air, and I pull it back to make an envelope. The problem, like for this, is I'm blowing the air out of this grill to the right here. That air is being pulled right back in, so it's not the greatly efficient design.
So it should be over there, and they shouldn't have one too close.
Would be better. I wouldn't say should be, but would be nice.
Better choice.
I would like to have that one little side there maybe blocked so it's not blowing right that direction, but you see them like that all the time.
Oh.
Yeah. It's not like, oh, they did that wrong, it needs to be fixed right away, but it would be better, yes. Yeah.
Get some flex duct and optimize the room.
That's our final.
If we're going to optimize the room, it wouldn't be a flex duct anyways, right? So.
Metal deck, so we can strap it.
But return air and supply air. So we're also going to get temperature, the temperature of the air coming in and temperature of the air coming out. Return air temperature and supply air temperature. Is there a difference in those two numbers?
Yes.
Yes, there is. The difference in those two numbers has a name. I threw my markers, but I don't have markers. All right, so I'm going to use this symbol right here. One side, notice the triangle, but one side, two sides of triangles are darker than one side of the triangle. That's a symbol.
I know, I've seen it in the thing too.
You know what that symbol stands for? What it's called? It's called delta.
There you go. It was in like 10 to 2 or something.
See, you know, you get all the college people with their Delta Pi, whatever sorority. We got our own. Yeah, we got HVAC Delta right there. But we call it Delta T. Delta T. We got our Delta T. Not Delta. We don't need Delta. We got Delta T. So Delta T can be many things. Two different points, but the same medium. So here, what we're talking about is the air coming in. So airs are medium. The air coming into our evaporator, and then the same medium air coming out of our evaporator. We're going to talk about other stuff later that's two different mediums, two different things. But for right now, delta T, the same thing. So it's going to be the temperature of the air coming into the evaporator minus the temperature of the air coming out of that. Okay? What are some things that will affect that? Humidity. Here's a good point. Normally people don't catch on that fast. My system has a certain amount of BTU capacity of cooling that it can absorb per hour. Follow me? If the air is dry and I'm not dehumidifying, then most of that energy, that capacity that I have, is used to take heat out of the air, which is sensible. So you'll have a really good temperature change as the air is going across that evaporator coil. But as the humidity goes up, I'm going to use capacity to pull that moisture out of the air. 970 BTUs for every 1 pound of water I pull out. So if the air is moist, I'm using some of my capacity to dehumidify. So if the air is moist, I'm using capacity to dehumidify. Do I have enough capacity left to change temperature?
No.
I do, but not as much. So on a humid day, the delta T across the evaporator can be less than on a dry day. A lot of people, I've heard people before say, oh, make sure your delta T is 18 and you're good. Oh, well, what about humidity? Humidity is going to play a part in that, right? So it's important to consider humidity on that as well. Willis Carrier didn't invent the air conditioner to have an 18-degree split across the coil. No, he invented the apparatus to control temperature and humidity. So you got to take into account your humidity as it goes across that coil as well. It is going to play a part in it. Does that make sense? So far, so good? Okay. So on the different units, you have different types of return air and supply air. The units we have out there in the lab, they're upflow. So it pulls the air in the side, takes the heat out of the air, blows the air across the top, which should usually be in the attic. But in commercial buildings, the units are going to be on the roof. So it's going to be pulling all the air from this room to the units, treat the air, blow that air back in. So first we're going to take you to the other lab. I want to show you how the ducts penetrate through the roof. And then we're going to come up here, we're going to climb up in the ladder, we're going to look at the ducts here and see how the different ducts are ran. Okay.